Okay, so we're going to continue on with graphing rational functions today. All right, so we'll pick up where we kind of left off yesterday. Son of a biscuit. Okay, so what do we do first when we see a rational function that looks like this one? Factor, absolutely, right. We want to factor, so we go ahead. What does the first one factor to? X plus 3x minus 5, I like it. And what does the denominator factor to? Very good. X plus 7, x minus 2. All right. Does anything cancel here? No. So what are we not going to have? A whole, right? We only get wholes when things cancel. All right. So we can go ahead and go through all of our steps that are still up there on the board. For those of you at home, they were the steps that I put up at the very beginning of the video yesterday. So hopefully you saw at least the beginning of that video and those steps. All right, so step 1 says to find the x-intercepts. And we do that by setting the numerator equal to 0 and solve. All right, so what are my two x-intercepts here? Very good. -3 and 5. All right, then we find our y-intercept. How do I do that? Plug in 0, absolutely. And we can do it to either form, right? The factored form or the original form. The original form is usually easier, all right? So we plug 0 into the original form. Everything with x's just kind of goes away. We're left with -15 over -14. So 15/14. All right, next we look for vertical asymptotes. How do we find vertical asymptotes? Set the denominator equal to 0. We do have to, how do we have to be careful about how we give asymptotes? Can we just write the number down? Yeah, for vertical asymptotes, it has to be x equals. For horizontal, it has to be y equals, horizontal or slant. We'll get to those tomorrow, though. All right. Asymptotes are lines, so they have to be written as such, right, as the equation of a line. So how am I going to write my vertical asymptotes here? Very good. X equals -7 and x equals 2. I don't care if you just separate them with a comma. I'm lazy, so I don't care if you are. Although delta math will probably make you put them in separately, right? Yeah. Delta math's kind of a stickler for precision, right? All right, so how do we find horizontal asymptotes? Yeah, compare the degrees of the numerator and denominator. It's very similar to last unit when we did limits as x goes to infinity, right? So how do the degrees compare here? They're the same. So it's 1, right? It's the ratio of the leading coefficients, in this case, 1/1. So we write that as y equals 1. We already said that there were no wholes. Of course, those only occur when a factor in the numerator cancels with a factor in the denominator. All right. And our last thing that we do is what? Extra points. Absolutely. Do we just pick any old random points? No. All right. We want to be strategic about the points that we pick.
Should we still pick 10 and -10?
Yeah, remember, you just do whatever your graph dictates. In this case, they aren't labeled, but yes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, it looks like a standard 10 by 10 graph. So yeah, we can definitely pick -10 and +10. All right, and how do we want to pick the other x values? Very good. Numbers on each side of any vertical asymptotes that we have. So we have a vertical asymptote at -7. So which numbers would I pick there? -8 and -6. Very good. And we have an asymptote at 2, 1 and 3. All right, again, you can plug these x values into either the original or the factored form, depending on which way your brain likes best. All right, I like to plug it in the original. All right, so plugging in -10, we get 100, plus 20 is 120, minus 15 is 105, and that will be over 100, minus 50 is 50, minus 14 is 36. Now, again, we don't have to be very precise with that. All right. What's that pretty close to? 3. Yeah, it's very close to 3. All right. 108 over 36 would be 3. So it's just under 3, right? And if you want to like kind of put that off to the side, you certainly can, right? We'll just say anything under 3 is fine, 2.9-ish, 2.8-ish. I'm not too picky about that, right? All right, so plugging in -8, right, we get 64, plus 16 is 80, minus 15 is 65, over 64, minus 40 is 24, minus 14 is 10, so that's obviously 6.5. All right, we plug in -6, we get 36, plus 12 is 48, minus 15 is 33. And just, if you catch me making a mistake, let me know. I try to go pretty quick. All right, plugging in -6 into the denominator, we get 36, minus 30 is 6, minus 14 is -8. All right, so what is this close to? -4, yeah, just over -4. So around -4.1, 4.2, somewhere in between there. All right, 1, this should be easy. We like 1. 1 minus 2 is -1, minus 15 is -16. Over 1 plus 5 is 6, minus 14 is -8. So that's just 2. Plugging in 3, we get 9, minus 6 is 3, minus 15 is -12. Over in the denominator, we get 9, plus 15 is 24, minus 14 is 10, so -1.2. And plug in 10, we get 100, minus 20 is 80, minus 15 is 65. Over 100 plus 50 is 150, minus 14 is 136. What is that close to? Yeah, it's just under 2, so 1.8, somewhere in there. Again, you don't have to be super accurate with those. Say that again.
Wouldn't that be under 1?
I'm sorry. Yeah, you're right. It's 1/3. Absolutely. So 0.3-ish, 0.33, anywhere in there. Everybody good thus far? Okay, how do we like to start our graphs?
With the asymptotes?
Yeah, the asymptotes, right? And asymptotes, of course, remember, aren't actually part of the graph. They're just the guides that help us draw them, all right? So I do them with dashed lines. So we have vertical asymptotes at -7 and 2. So -7 and 2. And we have a horizontal asymptote at 1. All right, so now we can start putting all of our points on here. All right, so we have x-intercepts at -3 and 5. We have a y-intercept at 15/14, which is just over 1. All right, we have vertical asymptote. I'm sorry, we already have that in there. We have -10, 2.9, so right in here. We have -8, 6.5, so right here. We have -6, -4.1, so right in here. We have 1, 2. We have 3, and negative 1.2. And we have 10. We said close to a third. Okay. So kind of with our experience from graphing these things yesterday and how rational functions really look, are each of these pieces fairly obvious of what to do? Yeah. All right. So here, of course, eventually I'll get to my asymptote there. What happens in the middle? Yeah, I'm coming down this way, right? And then I have to cross my x-axis here. All right, I have to hit these points. And then obviously I go up. Why can't I go back down? Yeah, there's not an x-intercept here, right? Remember, we can never, like, that's kind of one of the tricks that helps us always do the correct thing. We can't just magically create new x-intercepts, right? Whatever x-intercepts we told ourselves we had over here, those are our x-intercepts and our only x-intercepts, all right? And then over here, this is fairly obvious as well. This is one of our nice normal kind of little curvy pieces. And bada bing, we're done. Questions or concerns? What's the most annoying part about these? The extra points. Yeah. When you only have like a few extra points, it's not bad, right? But when you have a bunch of them, and especially when they're like funky fractions like that, it's kind of annoying, right? So why don't you go ahead and try this one? Oh, yep. What you mean, bud?
Yeah. Well, just because if something happens in the bathroom, they look at the cameras. Right. It's like a person in the room. Right. Yes. Absolutely. Accent subs. Yep. Indeed. I'm not picking that. Except with I'm just gonna butcher whatever. Any reason I can find to put a red X on there.
So if you plug in 0 and the entire equation cancels, what does that make the y-intercept?
The entire equation cancels. You should put 0 in there. It doesn't cancel.
0 plus 4.
There's 4. And 0 minus 4 is negative 4. So 4 times negative 4 is.
Oh, yeah, those are two.
Remember, it's much easier for the y-intercept to plug it into the original because you're much less likely to make a mistake like that. All right. So if you just look at it right there, like you just plug 0 in there, what are you gonna get? over. So that's so typically the y-intercept's a little bit easier than the original. Of course, you would get the same thing in the factor form, but it is much more likely to consume. You got to stay, huh?
Yeah.
I see you back.
Yeah.
Yeah, it's always annoying. Administration comes in every day. At least that's close to this version. We got one girl who was quarantined for 2 weeks. Yeah, who came back for 1 day last Friday, and then over the weekend has to
Oh,
so she's gonna be out first. She's gonna be here 1 day. Yeah. So.
Oh,
Yeah. Oh yeah.
Yeah, but he only took
She was here like 3 or 4 days.
So we put it at 10 in my grade. Keeping up with everything now.
She's doing it. Yeah. She the 1 day she was here, she actually came in early to make up the deadline she missing.
Yeah.
She's
That's all very good.
Yeah.
That's important.
Yeah. Well, I mean, with honest speaking, usually most kids are going to do at least enough to keep their head above water, you know?
Yeah.
Don't get me wrong, there's plenty of them that fall off the line, but they usually do enough. Whereas, you know, that happens in CP class. They will just do the 1 day more, come in, assignment the whole time while they're out.
Yeah.
And then that's when it becomes difficult.
Yeah, because it's just snowballs at that point.
And what they gonna do when they write it down?
They'll start it.
Going back there.
Seven
Can I go?
It just is. I'm gonna try it. Let me know how it goes.
Oh,
Oh, I'm just gonna.
does that make sense?
Yeah.
Yeah, it's a fine structure, like, so you're.
Should I do it right?
So then, this plus 0.
You literally just one example. I think that's
And we'll get to some like that.
You don't need that.
Alright guys, so are we ready to take a look at this one? No, she says no. Give me a minute.
I'm trying to grab.
I'm trying to figure it out.
I'll give you that.
What's that?
Who's the boss? Right. You don't know what they're gonna pull out.
Wait, John. So what do you mean? So then wait, what do I do both of them?
84 over 96. Yeah.
Whoa.
That's upside.
That's upside. Now you want to put that middle piece around your chin.
You just stole her phone. That kind of. I really know exactly what all the kids look like. Straight medicines.
I'm going to start in. Keep graphing. By the time I get to the graph,
It's not fair.
Not fair.
Even if it's
I'm a slow
I can't trust people that
burner.
work cities outside.
I'm a slow cracker. All right, guys. So let's take a look at this. All right. So, of course, we can factor. And these are both difference of perfect squares, correct? So we have x plus 4, x minus 4, and x plus 2, x minus 2. All right, so x-intercepts we get from the numerator as plus or minus 4. Y-intercept, we plug 0 into the original preferably, so negative 16 over negative 4 gives you 4. Vertical asymptotes we get from the denominator, so plus or minus 2. Horizontal asymptote, the same boring one we've had every single time so far, right? Y equals 1. Ratio of the leading coefficients. All right. Nothing canceled, so we have no holes. For extra points, we can still do our endpoints of our graphs, negative 10 and 10. All right, we have vertical asymptote at negative 2, so we can do negative 3 and negative 1. We have vertical asymptote at positive 2, so we can do positive 1 and positive 3. All right, so we go ahead and plug all these in. Negative 10, we will get 100 minus 16 is 84. Over 100 minus 4 is 96. Plug in negative 3. 9 minus 16 is negative 7. Over 9 minus 4 is 5. Plug in negative 1. 1 minus 16 is negative 15. Over 1 minus 4 is negative 3, so that's just 5. All right, now the great thing about these three, they're all the same. All right, and the reason why is because there was no b term in these quadratics, right? And of course, whenever you square a number, it doesn't matter whether it's positive or negative. Okay, so these will just kind of mirror each other. So 5, negative 7/5, and 84/96. All right, so now we can go ahead and put our asymptotes on here. So we have vertical asymptotes at negative and positive 2. And we have a horizontal asymptote at 1. All right, put all of our points on here. All right, we get x-intercepts at negative 4 and positive 4. We've got a y-intercept of 4. We've got negative 10 and just under 1. We've got negative 3 and negative 7/5, so not quite negative 1.5. All right. We've got negative 1 and 5. We've got positive 1 and 5. We've got 3 and negative 7/5. And we've got 10 and just under 1. Are all of these fairly obvious? Yes. All right. So this will come down like so. This will mirror it on the other side. And again, we of course cannot have any other x-intercepts, and our points tell us to do that anyway. So we're good. Is this what everybody got? Good times? Had by somebody somewhere?
Had by the guy that's doing your
Yeah, oh yeah, that guy's having a blast right now. Just killing it. Here, let's see how many I got right now. 99 plus. It quits keeping track at 99. Right. And that, yeah. And as soon as I like go to it and look at it, it starts over. So like when I showed you guys that first time, it started over. We've had over 99 since then. So that's awesome. All right, so let me see here. If this is just like the others, let's see. So plus 9 minus 2 plus 3 plus 1. Let's skip that one. Let's do, okay, let's look at this one. I like this one. Yeah. All right, so of course we want to factor. So here we're going to get x plus 5 and x minus 1. Down below, difference of perfect squares, we get x plus 1, x minus 1. What happens here? Yes, these are going to cancel. All right, so what does that mean we're going to have? A whole, okay? And as is, I was very specific about up on the steps yesterday when we talked about it. Once these things cancel, what are they no longer? Yeah, it's definitely not an x-intercept anymore, and it's not a vertical asymptote. All right. Once they cancel, it is a whole and only a whole. All right. You can only have one of those things at a time, right? An x-intercept, a vertical asymptote, or a whole. Right? You can never have more than one at the same spot. Okay. Question? I heard a so.
Sorry, I kind of jumped ahead, but
Nope, you're good.
what happens whenever our vertical asymptote equals -1? Or no?
Yep, we'll have a vertical asymptote at -1.
So we just not put it there since we have a whole?
No, the whole's going to be at +1, right? Because if we set x minus 1 equal to 0, right, then it's going to be, that'll be +1. But I have seen problems, like there are problems where it's.
So what happens with that?
Wait, you're a step ahead of your.
Yeah, we'll get to something like that. Okay, we'll get there.
What if both of them crossed out?
Um,
Or is that possible?
it is possible if everything crossed out. It'd be really weird. It would just be 1, right? So you'd have a horizontal line at 1, but then you'd have holes at the x coordinates of where the things cancel out. So it's possible. It's very rare and very boring, right? You'll never see it in my class, but it's possible. Sure.
We're doing extra points. You still go to the original problem.
You can go to either.
It would be easier.
It's going to be easier with the factored. Absolutely. Yeah, I would definitely do it on the factored one at this point. Yeah. All right. So let's go through our normal process here. So first we'll look at x-intercepts. All right. This canceled, so it's not 1 anymore. So we only care about this other factor. So we'll have an x-intercept at -5. Y-intercept, when we plug in 0, doesn't matter which one we plug it into now. They're both very easy. Either way, we're going to get +5. Right? Vertical asymptote. Of course, we only care about the one that is not canceled out. So that will be x is equal to -1. Horizontal asymptote, again, the degrees are the same, so we take the ratio of the leading coefficients. So again, y equals 1. All right, here's our new thing here. All right, we're going to have a hole. All right, and a hole is going to have ordered pairs, just like a point will. Okay, so it's got to have an x and a y coordinate. The x coordinate is very easy. We take whatever factor has canceled out, in this case, x minus 1. We set it equal to 0 and we solve. So that gives me 1 as my x coordinate. Okay, now to find the y coordinate, we plug it into what is left, right? So what is not canceled out. We can't plug it into the original or we'll get 0 over 0, all right? Kind of like when we did the divide out technique with limits, all right? So here we cancel this out. All right, we plug 1 in. I get 6 up top. I get 3 down below. I'm sorry, 2 down below. So 6 over 2 is, I jumped ahead of myself. Yes, 3. All right, so we're going to have a hole at 1, 3. All right, so we can still find some extra points here. Of course, when things cancel out, it actually makes the problem significantly easier, right? You're not going to have near as many points and vertical asymptotes to put extra points around and that kind of stuff. So we can still do our negative 10 and 10. Our vertical asymptote is negative 1. What's the only number I'm going to need around there? Somebody said it. Oh, do we need 0? No, why not? That's the y-intercept, right? When we plug in 0, that's always the y-intercept. So we need 2, right? Now, if you put 0 and 2 down here, is it going to hurt you? No, right? So if you don't remember right off the bat that you never need 0. Yes, sorry. Shoot. Who said shoot? No one. Anna never says anything in this class. All right. So we plug this in. All right. As was pointed out, it is easier now to do it in the simplified form. All right. So if we plug negative 10 in, we're going to get negative 5 over negative 9. So 5/9. All right, if we plug negative 2 in, we will get 3 over negative 1, so negative 3. And if we plug 10 in, we will get 15 over 11. All right, so we go ahead and start putting our stuff on here. All right, so we have a vertical asymptote at negative 1. We have a horizontal asymptote at 1. All right, we have an x-intercept at negative 5. We have a y-intercept at positive 5. We have a hole at 1, 3. So we go 1, 3, and we just put an open circle there. That's our hole. All right, we have negative 10, 5/9, which is just over a half. We have negative 2, negative 3. And we have 10, 15/11, which is just under 1.5. Right? Is this very obvious? Does it look like a normal rational function? Absolutely. And good there. All right, do be careful when you draw this part to not draw it through the hole. Right? Of course, with you guys, it's a lot easier. You have pencils. You can just erase that hole, right? But with me on this little device, it's not quite as easy. So that's it, right? It's really just like the very simple, like the very first rational functions that we started graphing yesterday. The only difference is it has a hole in it. But holes aren't terrible. They're really just another point, right? It's just an open circle instead of a closed one. Questions or concerns? Absolutely not. Do I ever model a problem and then give you one just like it to do? No. Good times, huh?
Oh, yeah.
And you're so lucky. You get to say the exact same thing. Hello, folks. Wow. It makes lesson planning a lot easier.
Yeah, true. Oh, I'd probably prefer just for
I do too.
just for that.
Oh, 5 and 1.
Absolutely not.
Okay, I didn't think there was a wall number 5.
Are you still on that phone?
Yes. I know, but it's good. I refuse to move on.
Such a day. But the X is. So now let's just go through all of our normal stuff like we did, right? So x-intercepts. Y-intercepts. Right? Well, normally we plug in 0. Well, that's what we got from what we canceled. So in this case, our y-intercept is actually going to be what?
Okay.
Does that make sense? So here, since it's a hole, you would just like.
Wait, what you got?
Okay.
Does that make sense? So we said.
I'm just. You always watch that. It's called.
Okay, and the horizontal asymptote. And you can look at the original formations, right? So how did the degrees compare? I got 72. So negative 1 because of 4. Okay, now to find the whole, we take what we canceled out and set it equal to 0. Well, there's nothing left to do, right? X equals 0, so my x is 0. Right, and then I plug 0 into what's left. Right? So 0 plus 3 is 3 times 2 is 6.
Or
6 11, right? 0
it's just one of those things that
minus
get
2
talked about, but never.
times negative 4 is 8. So 6 over 8.
We do that.
Yeah. Okay. 0. Yes, when the degree at the top is larger, if the degree at the bottom is larger than good times. Good times, good times.
That's about good time.
Yes.
For extra points, it's vertical asymptote. Yeah. That you go off of. One of the little extra points. Yeah.
But say that again.
Vertical. I don't know. I can only really show you.
Oh, okay.
So like, so vertical.
Thanks, Zach.
I'll put 2 extra one extra points.
Yeah, you can put 2. Yep, absolutely.
I don't know. I've explained it. Negative 10. Like that.
What are you talking about?
Not.
No, it's your fault. Why would you model a problem and then give one similar to it? It's a terrible idea.
That's like madness.
Right, it's insane. Insanity.
Thanks.
Very good about
Yeah.
This one is
Yeah, I see that.
So it's, you know, that's
this
That's very nice.
is 5x
Like-
plus.
Relatively peaceful.
I'm
That's two variables.
I get all.
Yeah.
Why'd you use
Now, for
Because this one
again, what's usually like, I don't know, the teacher.
Yeah.
What classes are they usually
It varies on what our needs are at the time.
Yeah.
Because some teachers, believe it or not, prefer to teach the lineage. And it's like, there's a class where I teach house 1 year long. It's gonna be free, like 1 prep, easy class. Like, you may have to deal with behavioral issues and stuff in class.
Right.
But you're gonna have much easier lesson planning and much easier grading. Right? So it's like, do you want your life outside of class? Or in my case, do you want your life inside of class?
Right.
Because with honors classes, during class is easy, right? Less behavioral issues, less, all that kind of stuff.
Right.
Whereas outside of class, you know, more rigorous lesson planning, much more difficult grading, much,
Yeah.
you know what I mean? So it's
Even
kind
just
of,
the nature of the content.
and there are plenty of teachers that prefer, like, I'll deal with jerks in class.
Yeah.
Make my grading and lesson planning, just take the whole course. You know what I mean? Like,
Yeah.
there's teachers that prefer it.
I
So,
haven't thought about that. Yeah.
so it really just depends on, like, what our need is at the time. It's often like, okay, whatever teacher left, what did they teach? Right? And then that's kind of usually what you get.
Oh, yeah, true.
I figured.
Okay, so this should be higher than this. Right, this is 1.3, this is 4, this should be up. And then it will be back on, you know. Yeah.
So just
I hear
guessing
it.
as
I
I
hear
go.
it. All right, guys, we ready to take a look?
Yeah.
All right.
All right, let's do it. So, of course, we want to factor first. So here we're going to get x plus 5 and x plus 2. Down below, we're going to get x plus 5 and x minus 1. So, of course, our x plus 5s cancel, right? So we're going to have a whole. And, of course, we need to remember those are no longer x-intercepts or vertical asymptote. All right, so we find our x-intercept, which is -2. We find our y-intercept, which is -2 also. All right, our vertical asymptote is x equals 1. Our horizontal asymptote is, yeah, shocker, whoops, that should be a y. All right, we are going to have a hole, we said. What's the x coordinate of my hole? -5. How do I find the y coordinate? Plug it into what's left, right? So we get -3 up top and -6 down below, right? So 1/2. All right, so now we find some extra points. We can do -10 and 10. Our vertical asymptote is 1, so we would say 2 and 0. Do we ever need 0? Nope. So we can plug 2 in here. So when we plug -10 in, we're going to get -8 over -11, so 8 over 11. When we plug 2 in, we will get 4 over 1, so 4. And when we plug 10 in, we will get 12 over 9. All right, so we start putting all of this stuff in. All right, vertical asymptote at 1, horizontal asymptote at 1. All right, we have an x-intercept at -2, a y-intercept at -2. We have -10 8/11ths, so less than 1. We have 2 4. And we have 10 12/9, which is 1 1/3. Are these pretty obvious? Yeah. And we're done. Oh, yeah. Sorry. Totally forgot about the hole. Let's do, where's my little mini eraser? There we go. All right. So our hole is at -5 1/2. So 2, 3, 4, 5. Hey, look, it was pretty good anyway. Got lucky. Boop. And boop. There we go. Good call. Right? You gotta love sound effects. I mean, it's gotta, if somebody, isn't here and watches the video later, it's gotta be somewhat interesting, right? All right. And let's see what else we got here. Oh, I like this one. Go ahead and just see if you can do this one on your own. It's a little bit interesting. I mean, it's actually kind of boring, but the first time you see it, it's kind of interesting. Good times. God bless somebody's.
I like the first one. It was very, like, walk
No.
Vertical asymptote
Huh?
would just be none.
No, no. There's nothing down there set equal to 0, right?
It's just none.
Exactly. Right. You can set 1 equal to 0, but 1 never equals 0. So, yeah.
So would the vertical asymptote be one or zero?
There won't be one. Because there's nothing in the bottom that can, right? You have to have a variable in the denominator, and once it cancels, it's
If the horizontal asymptote, if the degree is higher than the numerator, what is that?
There's no.
there's nothing.
He doesn't want more than that.
That is correct.
And then if it's in the denominator, it's 0, right?
Exactly. You guys are by far my best class, by the way.
How is this? Yeah, what points then?
Of course, now anybody that watches that video is going to be like, oh, fine. I see how it is.
Did you get extra points? Do we do extra points?
Yeah, you can.
10.
Just pick whatever you want.
What?
You really won't need to.
No extra points.
I mean, if you just do -10 and 10, you'll be more than fine. Although I think only one of them will be on the
I
graph.
just don't feel like doing.
I just don't feel like doing that, Mr. Krause. So, but this one's really easy to do. Like the math
Wait, is
is
this?
incredibly easy, right?
Yeah, once you get back next week.
Yep.
Does
Indeed.
not exist.
Indeed.
But you're right, like first time seeing this, it's like,
Right.
yeah, we're doing this. It's like, wait, what?
You can't really buy it.
That's not exist.
Like I said, it's actually really boring. But like the first time you see it, it's not.
Yeah.
I like how you're like introducing just a slight new twist.
Right.
It's like each problem
Absolutely.
in a different way.
Yeah. Right. Like
Yeah.
Start super simple,
Yeah.
gradually work.
Wait.
Interesting.
What?
Yeah.
Is it just that big?
A line.
What's the word for the squiggly line?
It's not a squiggly one.
No, it's just a straight line.
It's hard when you like when you
I have no graphic paper.
yeah. I have graphic paper.
I like my line.
Okay.
So if you can only see the first one anyways.
Yeah, you don't have to. Come on.
But you have to have my face.
But yeah, Anna, there's always plenty of graphic paper up here.
Oh, you're talking about if you turn it off. But I made a note that it's straight line.
There you go.
All
All right, guys. So this one actually goes quickly. So let's go ahead and take a look at it. All right. So of course we want to start with our factoring. So we get x plus 4, x plus 2. Of course, order is irrelevant there. So the x plus 2's cancel. All right, so we say, all right, x-intercept is what? -4. Y-intercept is 4. Vertical asymptote, none. There's nothing in the bottom to set equal to 0 anymore. Horizontal asymptote, none. I'm going to asterisk this just for a moment. We'll come back to it. All right. Do I have a hole? Yep. What's my x coordinate? -2. What's my y coordinate? 2. Very good. All right. You really don't need any extra points here. But if you really wanted to, all right, -10 and 10. All right, when you plug -10 up in here, you're going to get -6. When you plug 10, you're going to get 14, which obviously is not on my graph, right? So we start plotting all of this stuff. Well, no asymptotes, but we have an x-intercept at -4, a y-intercept at +4, and a hole at -2, 2. All right, we do have -10, -6. Yeah, what is this? Yeah, it's just a line.
Okay, now I know that I'm going to be going through this open circle here, but just live with it for the time being since I can't break up that line. What in the actual? All right. So, guys, it's just a line with a hole in it, right? Like, that's it. When everything cancels out in the denominator, you're just kind of left with, like, it's just the line y equals x plus 4, right? So a slope of 1, a y-intercept of 4. We just have that hole in it. That's it. All right. Now, I asterisked this horizontal asymptote down here, and we'll get into this a lot more tomorrow. All right. But I have alluded to it a little bit before. All right. That sometimes we have what is called a slant asymptote. All right. And your slant asymptote occurs, all right, whenever the degree of the numerator is exactly 1 larger than the degree of the denominator. All right, so the numerator here is 2. All right, the denominator, the degree is 1. All right, so since 2 is exactly 1 larger than 1, all right, we would have what's called a slant asymptote. Now, in this case, the slant asymptote is our graph. All right, but typically we will use synthetic division, or in a very ugly, nasty case, long division of polynomials to find slant asymptotes. I'm usually not mean. I usually don't make you do ones with long division, but but in this case, the slant asymptote is the actual graph. But we'll get into a lot more of those tomorrow. All right, that's going to be it for today. All right, so you actually have quite a bit of time to work on your Delta Math assignment, either the one that was posted today and or the one that you had from yesterday. So if you use your time wisely, you should easily be able to be done with both of them. And those of you at home, you call it a day.